Hello students, in this video we'll discuss Bernoulli differential equations. A first order ODE of the form y prime plus p of x y is equal to q of x y to the power n is called a Bernoulli differential equation. It is called one. It's important to note that these Bernoulli differential equations are not linear. I have this power y to the n over here, so this is not linear. It's not a linear ODE. However, we can make an observation about Bernoulli differential equations, and that is that if I divide everything by y to the power n, what will happen? So if I divide by y to the power n, I will have y prime over y to the n is equal to plus p of x. And then if I have y over y to the power n, that's going to be a 1 over y to the n minus 1 power over here. And then this will be equal to q of x. So I get rid of the y to the power n, assuming that y is not equal to 0. Now the observation over here to make is that what I have is if I look at this function over here, 1 over y to the n minus 1, let's consider that function over there. Let's let u be y to the 1 minus n, which is exactly this box term over here. And then what will du dx be? So du dx will be 1 minus n, and then y, I'm going to lower this by 1 to the negative n. And then I have a what? Then I have a dy dx. Okay. So that's my differential relationship between u and y. Now the important thing to observe over here is that now what I see in this problem is I see a y to the power, I see dy dx times y to the power n. So what this expression over here can be turned into, this first expression, that y prime dy dx over y to the n is really just du dx over 1 minus n. So I can replace this over here with 1 over 1 minus n by dividing it by both sides of the equation, times du dx plus p of x, and then this is exactly my u, is equal to q of x. And now I've taken the problem and I've transformed it into a linear problem. So now this problem over here is a linear equation, and we know how to solve linear equations. It's a linear ODE. So let's see an example of this. Here's an example. Let's consider y prime plus xy is equal to xy squared. So this, of course, is a Bernoulli form. And so let's just go through the procedure in making the substitution of the dependent variable to see what happens. Okay? So what we're going to do over here is we're going to divide by y squared. So if we divide by y squared, we're going to have y prime over y squared. And then we'll have a plus x over y is equal to just regular old x. And now the substitution we're making is we're going to let u be y to the negative 1. So our substitution is going to be, let's let u be y to the negative 1. That's the function right over here. Then what will du be? So du dx will be negative y to the negative 2, which is what we see over here, times dy dx. So this expression over here is really just nothing more than negative du. So what will happen over here is this will become negative du dx. And then this is going to be plus x times u is equal to x over here. And so now, what's my integrating factor? So I'm going to multiply through by this negative sign to make my life a little bit easier. So this is exactly the same thing as writing that u prime minus x u is equal to x. My integrating factor is going to be e to the integral of this thing over here. So my integrating factor is going to be, so our integrating factor is going to be e to the integral of x dx, which is e to the negative x squared over 2. So if I multiply both sides by e to the negative x squared over 2, what's going to happen? We're going to have u times e to the negative x squared over 2 prime is equal to x times e to the negative x squared over 2. Now we can integrate both sides And if we integrate both sides, I'm going to get that u times e to the negative x squared over 2. Of course, an antiderivative of this thing, this is, of course, is just the derivative with respect to x of e to the x squared over 2 with a negative sign. So this is going to be e to the negative x squared over 2 with a negative sign, because we can just check what the derivative of this thing. The derivative of this thing is going to be e to the negative x squared over 2, and then times just x. So that works out perfectly, plus a constant c. So therefore, u is what? So u is going to be the e to the negative x squared, so we get a negative 1 plus c e to the x squared over 2 with a positive sign, positive x squared over 2 like so. And then what is y? Y is the reciprocal of this thing. So our solution y is going to be what? Our solution y is going to be 1 over negative 1 plus c e to the x squared over 2. And that is the general solution of this example, this Bernoulli type differential equation. Of course, this is a nonlinear first order differential equation, so the change of the dependent variable was what allowed us to solve this problem. Thank you very much.